Good afternoon, students. Let us now discuss the derivatives of higher order. When we say higher order, it means that after getting the first derivative of a function, we now proceed to getting the second derivative of a function, then the third derivative of the function, and so on and so forth. Okay, so let's have one example here. Example number 1. What is the fifth derivative of the function f of x, which is equal to 9x to the fifth plus 2x to the fourth plus 3x squared? So we first get the first derivative in order for us to come up with the fifth derivative. So the first derivative is 45x to the fourth plus 8x cubed plus 6x. I hope you already understood that, alright, based on our previous videos. Okay, then the second derivative is 180x cubed plus 24x squared plus 6. Then the third derivative is 540x squared plus 48x plus 0. Then the fourth derivative, 100 or 1080x plus 48. And then finally, for the fifth derivative, we have 1080 plus 0 or 1080. So this is now the answer that we are looking for. Example number 2. This example is taken from Tisiwag by Lighthold, The Calculus with Analytic Geometry by Louise Lighthold. Okay, so we are asked to determine the third derivative of this one. Okay, so first is for the first derivative. Now that's 2, then the derivative of sine x is cosine x. Then the derivative of cosine x is negative sine x times positive 3, that's negative 3 sine x. Then the derivative of negative x cubed is negative 3x squared. I hope you were able to follow based on our previous videos. Okay, so the derivative of cosine x is negative sine x times 2, it's negative 2 sine x. The derivative of sine x is cosine x times negative 3. It's negative 3 cosine x. And the derivative of 3x squared is 6x. Let's proceed to the last, the third derivative. The derivative of sine x is cosine x times 2. It's negative 2 cosine x. The derivative of cosine x is negative sine x times 3, so it's positive 3 sine x. And the derivative of negative 6x is negative 6. So this is our final answer. Very easy. Okay, because these are problems that are not much complicated. All right, especially if we have problems involving radicals, no, rational exponents. So this would be difficult to determine. It would be a challenge, no, to determine either the fourth or the fifth derivative. Let's have here one last example. Again, this problem is taken from the book of The Calculus with Analytic Geometry by Lighthold. Suppose that we are given 4x squared plus 9y squared equals 36. Then let's find the second derivative by implicit differentiation. Okay, that is d squared y dx squared. So this is our given equation. So we have 4x squared plus 9y squared equals 36. The derivative of 4x squared is 8x and the derivative of 9y squared is 18y. And since we are differentiating y, we have dy dx. The derivative of 36, a constant, is 0. Then 18y dy dx is copied here. And 8x is transposed to the right side so that it becomes negative 8x. Then transpose 18y to the right side so that becomes negative 8x over 18y, which when simplified is equal to negative 4x over 9y. So this one is our first derivative but not our final answer yet. So to determine for the second derivative, then we are going to get the derivative of this. So we apply our u over v, which is v du minus u dv all over v squared. So we have 9y. Then the derivative of negative 4x is negative 4 minus negative 4x times the derivative of 9y, which is 9 dy dx, because we are differentiating y, all over the square of the denominator, which is the square of 9y. Okay, now after which we are going to multiply 9 times negative 4 to come up with negative 36y. The negative times negative 4x is positive 4x times 9 is positive 36x. And then we are going to replace or substitute negative 4x over 9y to our dy dx, so that we have this now. Alright, then copy our denominator, or of course square the value, square 9y, so that we have 81y squared. Then let's simplify that. So as you can see, this will be negative 36y and this will be cancelled. You have 4 here, so that's negative 16x squared because we have 2 x's here. So you have negative 36y minus 16x squared over y, and copy the denominator 81y squared. Then this is understood to be over 1, so that our LCD is y. And then, of course, divide by 1, y divided by y, and multiply y by negative 36y. Then you have negative 36y squared minus y divided by y is 1. And so times 16x squared is 16x squared. And copy 81y squared. Now, if you can remember your complex fractions, so we have to copy the grand numerator. Okay, or in this case, I directly factor out negative 4. Okay, because these are all negative, so I take out the negative sign as well as the common factor 4. So 36 divided by 4, or negative 36y squared divided by 4 is 9y squared, and negative 16x squared divided by negative 4 is positive 4x squared, all over y, times the reciprocal of our grand denominator, which becomes 1 over 81y squared. So after which I arrange this order so that I could have 4x squared plus 9y squared. But anyway, that's commutative property. Why did I arrange that? So that it could be clear with you that I'm going to substitute 4x squared plus 9y squared by 36. Okay, so 4x squared plus 9y squared is now replaced by 36, or substituted by 36. Multiplied by 1 is 1. So you have negative 4 of 36 divided by the product of y and 81y squared. So the product of that is 81y cubed. So negative 4 and 36, so there is still a possibility of cancellation, so that you have 4 here and then you have 9 here. And so the final answer is negative 16 over 9y cubed, which is what we are looking for. Okay, so that's how we get the second derivative by implicit differentiation. Thank you very much. This is Dr. Batukan saying, mathematics is easy to learn when one learns with enthusiasm. Bye!